Hi, good morning everyone. Welcome to our new chapter 16, Polygons and Quadrilaters. Here we will study about polygons, types of polygons, diagonals, quadrilaters, angles and properties of quadrilaters, and types of quadrilater. If you saw this figure, this is a 10-gram figure, consists of 7 pieces cut from the square. Number is marked on that 1, 2, 3, 4, 5, 6, 7. If you arrange the spaces in different ways, you will get triangle, rectangle, pentagon, parallelogram, hexagon, and you can draw more polygons using these pieces of 10 grams. Next is, what is the polygon? Here, according to this chapter, polygon, the word polygon is derived from the Latin word polygonum, means many angled. So if you saw around us, like there is many figures you saw, like school, home, markets, we are surrounded by different kinds of polygons in the shape of buildings. So simply we can say that polygon is simple closed curve covered by 3 or more line segments. The line segment we call it sides, and intersection of sides we call it vertices. So polygon are classified and named on the basis of number of sides they have. So if you saw it figure, there is different sided according to side name identify triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, decagon, and dodecagon. Next is, you have regular and irregular polygon. That is a type of polygons. Regular polygons means when all measurement of all sides are equal to each other and all angles are equal to each other. Irregular polygon means if opposite sides are equal to each other and opposite angles are each other. And another way we can say that in irregular polygon, measurement of all sides are not equal to each other and measurement of all angles are also not equal to each other. Next type is convex and concave polygons. A polygon in which the measure of each angle is less than 180 degree is called convex polygon. In a convex polygon, all the diagonals lies inside the polygons. A polygon in which the measure of at least one angle is more than 180 degrees is called concave polygon. If you saw the figure, convex polygons diagonals lie within the figure, while in concave polygons diagonals lies outside the polygon and within the angle. If any angle increases 180 degree, so that is not a convex polygon. And remember one thing in this, an n-sided polygon has n angles and n vertices. For example, a polygon with 6 sides has 6 angles and 6 vertices. So, but if it is a regular polygon, so all regular polygons we call it convex, because in all regular polygons angles inside the angle, if you count at single angle, any single angle, so that not crosses 180 degree, that will be less than 180 degree. So next is diagonals in polygons. If you have to identify how many diagonals in the polygons, the diagonal of polygons are line segment connecting two non-adjacent sides. If you look at the figure, triangle 3 sides 0 diagonal, quadrilateral 4 sides 2 diagonal, pentagon 5 sides 5 diagonals, and hexagon 6 sides and 9 diagonals. But we can calculate any polygon number of sides according to number of sides, how many diagonals will be included in this. Like we have the formula n into n minus 3 by 3. From this formula we can identify any polygon like triangle, quadrilateral, pentagon, hexagon, and more sided polygon. So we identify the diagonals from that. Like in triangle, when we apply the formula, we receive 0 diagonal, quadrilateral 2 diagonals, pentagon 5 diagonals. So next, according to this, is if I have one question, if I have a figure decagon, I want to find the number of diagonals. So I have the formula n into n minus 3 by 2. So what I will do, so n means number of sides in the polygon. So here is a 10, 10 minus 3, 10 into 10 minus 3 by 2 gives you 35. That means there are total 35 diagonals in a decagon, that is a 10-sided figure. Next is our topic is interior and exterior angles of the polygon. Those angles which are lies inside the polygon within the curved side of the polygon, that we call it interior angles, and those angles lies outside the line, outside the side, we call it exterior angles. Here if you look at the figure, in this 1, 2, 3, 4, 5 are interior angles that lies within the closed figure, and another angle 6, 7, 8, 9, 10 that are group of angles. We call it exterior angles that lies outside the closed figure. But if you saw this like 2, 7, 1, 6, 3, 8, 4, 9, 5, 10, that shows the linear angles, that is linear pair angles, that is exactly same equal to 180 degree. That means if you add interior exterior, that combined give you 180 degree. Now how will you find sum of interior angle of the polygons? So if you have to identify what is the measurement of all the angles of interior angle of the polygon, so suppose you draw the quadrilateral, pentagon, hexagon. These three figures, quadrilateral has 4 sides, pentagon has 5 sides, and hexagon has 6 sides. If you convert this side divided into small regular triangles, like in quadrilateral there will be a 2 triangles, pentagon 3 triangles, hexagon 4 triangles. So if you have to identify to measure the angles, what is the measurement of inside interior angle measurement, so you have to find. So in this, if you saw that quadrilateral, there is 2 triangles within, and measurement of sum of measurement of one triangle is 180 degree. That means when you multiply 180 degree 2 times, that gives you 360 degree. So according to this quadrilateral, sum of all the interior angles of quadrilateral is 360 degree, as pentagon has 3 triangles. So 3 into 180 degree gives me 540 degree, and hexagon there is 4 triangles, and 4 into 180 degree gives me 720 degree. This way we can identify, but that is only for the few like sided polygon we can identify, but other for you can use the formula number of triangles into 180 degree. Like we have the figure like 15 gone, and that means polygon with 15 sides. You have to find the measure of one interior angle of the regular figure. Regular means all sides and all angles are equal to each other, and we use the formula n minus 2 into 180 degree. N means number of sides. So 15 minus 2 into 180 degree gives me 2340 degrees. That means that is the sum of all the interior angles of regular 15 sided polygons. But if you have to find the measurement of one angle, then you have to divide measurement of all the angles divide by number of sides. That means sum of all the angles divide by number of sides, that gives you 156 degree. Now find the number of sides of regular polygon with each angle measuring 120 degree. If you have regular polygon, one angle is given 120 degrees. So how we will find the number of sides in the regular polygon? So first we will consider number of sides of regular polygon be n. Then if measurement of one angle is 120 degree, according to that sum of angles will be 9 into 120 degree. But according to the formula, this is n minus 2 into 180 degree. Then when you equalize with each other, you find the value n is equal to 6. That is number of sides of the polygon in which one angle is 120 degree. So here in this case you can find easily by comparing n into 120 degree is equal to n minus 2 into 180 degree. N minus 2 into 180 degree is the sum of interior angles of all of angles of polygons of n sided. So here when you compare, you will find the n value. One more question: if you have in interior angle of hexagon in form of x is given, so how you will find the measure of each angle of the hexagon? Look, hexagon has total 6 sides. If you have to find the sum of all the interior angles of the hexagon, you apply the formula again, n minus 2 into 180 degree. N is here 6 sides because that is the 6 sides of hexagon. So that means sum of all interior angles of hexagon is 720 degree. Now you add all the given angles in form of x and is equal to 720 degree. Add the like term, you will get the answer after cross multiply as 640 divided by 16, because 720 minus 80 give you 640, and when cross multiply that gives you 40 degree, because sum of all the angles divided by number of sides give you measurement of one angle. So if one interior angle of heptagon means who has 7 sides, is given 210 degree, if the remaining angles are in the ratio 1:2:3:4:5:8, then how will you calculate the size of the greatest angle? So which one is the greatest angle? For that, first you will find sum of interior angles of a heptagon, n minus 2 into 180 degree. Here n is 7 minus 2 into 180 degree give you 900. That is sum of all the interior angles of the heptagon. So if one angle is greater than another, so here if you saw in the figure, only 6 angles ratio is given to you, and one angle actual measurement is given 210 degree. When you add all the angles, you will get the answer. If you add all the 7 angles, that is sum of interior angles given to you in your question is 900. So when you add all x values, that give you 23x is equal to 900. After dividing, you will get each angle is 30 degree, and by applying the value you will find the greatest angle. Next is the sum of the exterior angles of the polygons. If you have to find the sum of the exterior angle of the polygon, so suppose here we draw 3 figures: quadrilateral, pentagon, hexagon. So if you saw in this figure, 1, 2, 3, 4 is the exterior angle of the quadrilateral ABCD. Here 1, 2, 3, 4, 5 exterior angle of the pentagon ABCDE, and hexagon ABCDEF. 1, 2, 3, 4, 5, 6 are the exterior angle. If you join all the angles, like cut off the angles of each polygon and arrange them together, so you will find that all form the complete circle, and complete circle angle is 360 degree. That means each if how many doesn't matter how many sides of the polygon are there, and sum of all the exterior angles is always equal to 360 degree. So as the angle of each polygon form a complete angle, that means sum of exterior angle of the polygon is equal to 360 degree. But if you have to find the one angle, like measurement of one angle, so what you will do, so you will divide 360 by number of sides. So each exterior angle of n-sided regular polygon is 360 degree by n. Suppose I have a question, I have a figure is given. Here if you look at this, you have to find the x degree and y degree value. So if you look at this, 82 degree and y degree is a linear pair, angle in a straight line. From that, if you find the y degree, so that gives you after subtraction 180 degree minus 82 is equal to 98. Now if you look at all the exterior angles here, 60 degree, y degree, x degree, 146 degree. We just have done, if any doesn't matter how many sides are there, measurement of all exterior angles, how many angles are there, and whatever outside angles of any polygon is there, sum of all the angles always is equal to 360 degree. That is exterior angles, not interior angles. Interior angle has different measurement. If you add all the angles, equalize with 360 degree, you will get x value is 56 degree, and y